let's start. I will start by introducing all the speakers that we have today. It will be very rude, but I will start by myself because I will just be the moderator. So I will give the floors to all the speakers. My name is Benjamin Gass. I'm the Business Development and Marketing Manager for East Africa for Elephant Vert. And I will be the person who answers the question on the chat. I will also be the person who will give the floor to people if they have questions. And I will also introduce our speakers and give them the floor. The first person I would like to introduce first is Peris. Peris is a biotechnologist and experienced in agriculture biotechnology for 6 years, and marked by a professional and personal growth in qualitative and quantitative production of organic bioproducts, generation of growth in product production, formulation, and potentially through collaborative efforts, and a continuous build up in organizational leadership. And she's the product manager for Elephant Vet. The second speaker is Mariam. She's an agronomic engineer. She worked in R&D at several universities for more than 7 years. She holds a master's degree in plant breeding, and she's pursuing in PhD in plant genetics. In recent years, she started working in the agronomical industries and joined Seipasa last March as a product manager, and she's responsible for technical assistance and strategic development for Europe, Africa, and Middle East region. So thank you so much for being here, Paris and Maria. Luca. So Luca holds a master's degree in agronomy with a specialization in marketing. With over 8 years of experience in the conventional crop protection industry, he has focused on biocontrol solution in recent years. For nearly 3 years, Luca has been the biocontrol product manager at the group level at Elephant Vert global group. And in his mission, he oversees the international development of the biocontrol product range, defines strategic direction, support market launch, and provide technical and strategic guidance to subsidiaries and contributing to the promotion of sustainable agriculture practices worldwide. The next guest that I will introduce is Enrique. Enrique is an experienced agronomic engineer with over 15 years in the agriculture sector. He has extensive expertise in designing and managing field trials, a role he excelled in for like several years before joining Seipasa. For the past 7 years, Enrique has been instrumental in overseeing efficacy and R&D trials at Seipasa, accumulating like in his current position as Chief Technical Officer, where he leads the company's technical strategy and innovation initiative. And last but not least, we have Abdelatif. So Abdelatif is an agricultural engineer specializing in plant and environmental protection, with more than 12 years in the sector, especially as sales director in Moroccan phytosanitary companies. He's currently holds the position of Business Development Manager, Africa and Middle East within Seipasa. Thank you so much for being here, all of you. I know we can't do the round of applause, but that's in your heart. And we'll directly start with the webinar. And my first question will be for Paris. Paris, for you, what's the plant disease?
Okay, I would explain plant disease as a series of visible responses from a plant to a pathogen or unfavorable environment condition that result to advanced changes in the form or the formation of the plant, which may lead to partial impairment of or death of plant parts or the whole plant. Okay, we have two causes of plant disease, where we have the environmental stress or the pathogens, infections brought by pathogens. And when we talk about pathogens, there are four common plant pathogens, where we have the fungi, the bacteria, the virus, and the nematodes. On the fungi, we can mention on botrytis. Examples of fungi, we can have botrytis blight in roses or on apples or pears. We also have the mildew, the downy mildew or the powdery mildew, which are caused by various fungi in various orders in the plant kingdom, in the animal kingdom. And also we have root rot, which is caused by some species like Fusarium or Phytophthora or Rhizoctonia. Those are the types of species that cause root rot. We have also rust, which are caused by fungi in the order of Puccinelles. And then from here, we have bacteria. Bacteria, we have examples like the fire blight caused by bacteria, by gram-negative bacteria. Example of the genus that cause the fire blight, we have the Erina amylavora. We have also the bacterial leaf spots caused by various bacterial species like the Xanthonomas or the Pseudomonas. We also have the crown gall caused by agrobacterium. And then we go to viruses. The examples of viruses, we have the rosette virus in roses. We have the mosaic viruses in like the tomato or the tobacco. We have also the cucumber mosaic virus in the mosaic virus class. We also have the yellowing viruses, like in the sugar beet. We have the beet chlorosis virus. We have the beet yellow virus. We have the beet meal yellowing virus. We also have another category of stunt viruses where we have the peanut stunt virus or the rice rag stunt virus. And nematodes, we have the main class. We have the root knot nematodes. We also have the cyst nematodes or the stunt nematodes. And then from here, we're going to talk last but not least, we also have another pathogen that cause plant disease, which are the parasitic plants. And then from here, we have to talk about how the disease develop. And we have three elements of the disease development, where we have the host plant, we have the pathogen, and we have the environment conditions. First, we start with the host plant. The host plant can be divided into three groups: the resistant plant, or the susceptible host plant, or the tolerant host plant. For a disease to occur, we must have a susceptible host plant, which is not immune or can't resist the attack from any pathogens that we've mentioned above there. And then we have the pathogen. The pathogen must be virulent, that it has the ability to cause the disease, and also it has to occur in abundance for it to be able to cause a disease. And also what matters also in a pathogen is the stage of the pathogen, because some plants can resist a stage in a pathogen or in the life cycle of a pathogen. And then from there, if you have a conducive environment condition, a disease now will occur. And also in that interaction, in that triangle of disease development, we have time and also human activities, which play a part in making the disease occur in those three columns: the host, the susceptible host, the pathogen, and the favorable environment condition. And then from there, there's a way disease occur, the pathogenesis, the disease development, where we'll start by inoculation. Inoculation is the first introduction of the pathogen to the host. That is the first contact that requires for a disease to occur. And in inoculation, the main important thing to happen is the attachment of the pathogen to the host, where there are various mechanisms where the pathogen can produce some enzyme to make it adherence to the host plant. And then after the inoculation, there's penetration. Penetration occurs in three forms. We have the pre-penetration, we have the penetration itself, and the post-penetration, now which is also called as infection. For pre-penetration, it's where the pathogen germinates before penetration. It germinates when the environment conditions are conducive for it. And then from there, it penetrates through the natural openings of the plant where we have the stomata or the lenticels, or it can do direct penetration, or also it can get into the plant through wounds caused by the injuries, maybe from us human beings. And then once it's inside there, now we got the post-penetration occurring, now the infection. There we have the invasion and colonization, where the pathogen acquires as much nutrients from the plant and also multiplies when inside there. That's how colonization occurs. And inside there, the pathogen starts to secrete its own enzyme or toxin or the growth regulators, which affect now the cell metabolic processes like the phytosynthesis or respiration, or also the translocation of mineral salts and water throughout the plant, which now affects the plant's physiology and anatomy. And that's where we get to see our first symptoms. And from now, the inoculation until the time we get to see our first symptoms, that is what we call our incubation time. And then after manifestation of the symptoms caused by the pathogen has to look for another tissue to infect or another plant to infect for it to continue its cycle. That is called dissemination. After the pathogen builds up inside the tissues, it prepares to get a new host. And for it to disseminate, we require environmental conditions like wind, like water, and also human beings can be able to move the pathogen from one part to another. And then for bacteria, we have water splashes, which is the main method or means of moving it to another plant. For viruses, we must require a vector. And for nematodes, they can move through the soil movement. And then from there, in case there is no a host or the environment conditions are not favorable for the growth, the spores of this pathogen, they get into means that makes them survive in those conditions where they incubate themselves until they wait for favorable conditions for it to grow again. Okay, our main pathogen among the four that we've mentioned there above, the fungi is the main cause of disease in the plants, where it has like 85% of it causes like 85% of plant diseases. And they require this because they require plants to survive. They don't have chlorophyll, that means they don't make their own food. And also another reason as to why they're so successful into causing plant disease is the adaptability, where they are polyphagous. They feed on various hosts. Also, they secrete enzymes that enable them to get into their plants. And also they have rapid growth through exposed to mycelium in that way. And then for dormancy, where they are able to protect themselves from advanced or extreme environment conditions.
Thank you so much, Paris, for everything. It was very, very, very interesting to learn more about all the things that we can find on the soil or also like in the air. And me, I will just do a quick breathing, but I think Paris already like explained the fungal infection about the sign and the symptoms. So I will be like very quick on this one. So first of all, what I would like to say is the distinction between this, the sign and the symptom that you may have in the nature. So first of all, what's a symptom is like the change of a plant appearance or function, such as the discoloration, wilting, still growth, compared to like a sign. A sign is a physical evidence of this pathogen, such as a fungal spore, bacterial ooze, or like nematode. We decided today to have a quick focus on some of the main fungal infection that you may find in the field currently. The first one will be like powdery mildew. Powdery mildew, what's the factors of powdery mildew? It will be the warm, the dry days, followed by the cold, the humid nights that we may experience currently in East Africa. And what's the main symptom that we may recognize a powdery mildew is the white powder that you have over the leaves and sometimes on the stems and the buds. And also this powdery mildew will attack leaves and bloom disfigured. And the main damage that you have if you have this powdery mildew, it will be the reduce of the plant growth and vigor and the loss of the yield. The second main issue that we may have currently is the downy mildew. Downy mildew factors are like the cold between 10 to 22 degrees Celsius, the wet condition with high relative humidity that we have currently in East Africa with the rainy season. And how you can recognize it is by the patchy purple or brown discoloration bound by the leaf veins on the upper leaf surface, and also like the downy like tuft of the white to the purple gray fungal growth on the lower leaf surface. And this symptom can cause like the loss of the yield. We also decided to also focus on botrytis. Botrytis factors may be cool, humid weather, rainy weather, with symptom of like grayish brown, fuzzy, and woolly mold invasion. And also, it will prevent very badly the bloom to open, and it will cause like the bloom petal to turn like brown and shrivel up. And it will be a damage of course, like loss of the yield. We'll also talk about rust. Rust factors may be like cool, moist weather, especially when it's rainy, foggy, or like a misty condition. And how you can find the rust in the nature, you will find like the orange or the black spot, like pastel, on the underside of the leaves or on the entire leaves, and sometimes even on the stem. And the stem will be curling, and you will have like a distortion of the stem. Damage will be the fall of the foliage and also like the loss of the yield. And finally, we will also focus on the black spots. Will be caused by the cool and the moist weather. And you may see this in the nature by the black spot all over the foliage of the rose bushes. And also you can see it by the risk of total like defoliation. Damage, it will be, of course, like the plant vigor reduction, and it will also be like the plant will be very more sensitive to other like stresses and damages that you may already have by the cold and the moist weather. And finally, it's not a fungal infection, it's more like a bacterial infection that you may have in your culture. It's agrobacterium. So agrobacterium factors are like infected plant material, lack of hygiene and farm equipment. You will find it by cause conquerors called like a Fungal that you start as like a small swelling on the wooded plant parts. And after it will create like this young tumor that very soft, creamy white and rounded. And with edges, if you wait it, it will become like irregulars and may turn brown or dark. And what's the damage of it is like the stunted growth, and also like the plant will be more sensitive and susceptible to like a secondary like infection, and also some infection by the environmental condition. And to conclude this last part, we would like to also talk about like the IPM, so how to manage a fungal infection. As you can see on the screen, we have like this IPM pyramid that's like a visual representation of like the comprehensive approach to pest management that prioritize like prevent and less harmful like methods over reactive and potentially like harmful ones. So it emphasizes the importance of combining multiple strategies to achieve like a long-term sustainable pest control. At the bottom, you have the first prevention and economic practices. So in prevention, you may have a crop rotation, so alternating like crops to disrupt like the pest life cycle. You have also like resistant varieties, so planting like more resistance and less susceptible like pests to suppress like pests and improve like the soil health. You have intercropping, like planting different crops together to contribute to confuse like the pest and promote like some beneficial insects. You also have the protection of enhancement of beneficial, so conserving and encouraging natural enemies of pests. And you have also like the soil and the media management that's in the soil currently. You take a preventive measure in the initial stages to clean your soil by careful. You have to be very like careful when you apply like the manure. You also prefer like sanitized compost than direct manure. You can also, you know that some manure can carry like diseases, so you have to be careful. You can also like prepare your compost for bedding new plants. You need to shift or screen the compost, so it will be more air that you bring on this compost, and to also avoid any disease or fungal disease. And by sifting the compost, you remove like also the non-decomposed like component that you could damage the new plant roots. And it will also, what I said, like aerate the compost material. And the last one for prevention is to enhance like microbial life. It means that in general, like you make sure that you enhance like the microbial like life both in your soil and on the foliage. The more you have microbes, the more difficult it's for a pathogen to establish, to construct, to also create a life cycle, and they will fight for like the space. The second one is decision and detection. You have two ways of detection and decision. The first one is monitoring by regularly like inspecting crops for sign of pests and disease. And the second one is using weather data and pest life cycle information to predict the outbreaks. After we have the mechanical control by it's both three control. The first one will be mechanical, physical, and natural control. So by hand picking the pest, physical barriers are like the net, the traps, and also using beneficial organism as the predatory insect to help you with this one. The second one will be biological control. It's introducing natural enemies or pests in your crop. You have a good way to do it is by using biostimulation. You're using biostimulant that you will boost the crop vigor, and you will also boost the immune system of the crop, and you will also like prevent the apparition of fungal infection. You can use product called like Elictor, or you can use also other product as Novastim, for example. And at the end, you have the last control. The least that you have to use is to use pesticide really like as a last resort, and only when it's very necessary. Because you know, when you use chemical spray, you make sure to limit overuse of organosilicon. Why? It's because that it can scorch the plant. And the more you limit this micro wound on the plant, the less fungal infection problems you may have. And to also conclude on this part, I would like to also highlight different principles. The first one is prevention is better than cure, for example. So by focusing on prevention measure, like growers can like reduce the need for more harmful control methods. Also, it's not because I'm talking about decision, I'm talking about mechanical, that a combination of strategy may not be used. A combination of strategy is more effective. If you use IPF method, you may involve like using a variety of technical techniques to manage pests, taking into account that the specific crop, pest, and environment condition. And last but not least, clinical control should be your last resort. By following all these principles of IPM, you, growers, farmers, customers, you can achieve sustainable pest management, and you can also protect the environment and produce like a high quality crops. And now I will give the floor to Mariam to introducing a new product that we launched today with Elephant Vert East Africa called Fungicide. Mariam, the floor is yours.
Thanks a lot, Benjamin. So today we will try to introduce a new product that will be distributed by Elephant Vert in East Africa called Fungicide. Here we are going to talk about the characteristics and the features of the product. It's a biological product based on a microorganism called Bacillus subtilis, and it's a product that was exclusively developed by the company, by Seipasa. It's an exclusive strain, an exclusive formulation, and we are going to see some more details about the formulation and about the strain, also in the characteristics of the strain. The product was designed in order to offer to the plant a preventive action against different type of fungicides. The product offer a broad spectrum of activity against different type of pathogens that we are going also to see in details, from soil diseases to foliar diseases and so on. The product has been registered in Kenya and it's approved, so it's going to be available for you to if you are interested to use it. Also, here we are talking about a biological product, so it means that we are providing an eco-friendly product that will help the plant against different type of pathogens or against different type of attacks. But also we are by the use of the product, we are reducing the use of chemicals, and also we are respecting the agrosystem, the agrosystem, and helping the plant with other means which are friendly to the environment. So let's go and see some details about the product. So one of the main advantages of the product is the formulation, which is this very specific formulation that was developed in our laboratory with our R&D team, that offer a very good stability of the product in different type of conditions of storage. The product has been tested in different temperature of storage, and here, as you can see from the photo that we have in the screen, in comparison with another product, which is a very similar product containing a Bacillus subtilis strain, there is no phase separation of fungicide in case of a long storage. So that's a very good feature, because we are saving the product, and we are providing a good stability of the product that could goes to 2 to 3 years after storage, and you will be able to use the product without any problem. Also, a very good advantage of the product is the absence of the residue at the level of the fruit or at the level of the leaves. This is a very important feature also for the farmers. Once you apply the product, there is no risk afterwards if you want to market the fruits. And also, as you can see here, in comparison with another product, there is a clear difference in the photo, so there is no residue on the fruits. A very important aspect also is regarding the mixability of the product, because generally products containing this type of microorganisms, especially Bacillus subtilis, they show some limitation once you try to mix the product with other fungicide or other type of plant protection products. Especially products containing copper or sulfur. In our case, we have been testing the product and we have been carrying out several trials with the product with different type of coppers, from copper salt, copper gluconate, copper oxychloride, and we have been able to maintain the viability of the strain, and we have been able to maintain the same activity of the product even with mixing it with copper or with sulfur. So we are providing a strain which is also very stable, and that will permit to the farmer to use it in different combinations with different mixes in case he needs to apply it in combination with other products. Okay, so here we are going to shed the light on the mode of actions of the product. So basically we are talking about 3 types of mode of actions. First, we are talking about the direct antagonism of the strain. The direct antagonism relies on the capacity of the strain to colonize the plant and to colonize the space and the nutrient existing in the plant. So it's a kind of competition against the presence of other type of pathogens or other type of microorganism in the plant. So this rapid capacity is related to the biofilm development. So once you apply the product, you get the development of the biofilm. Here we can see a microscopic image where you can see the rapidity of the strain and the rapidity of the colonization of the microorganism, and it's a way to compete against other type of pathogen. And the second mode of action is related to the antibiosis. The antibiosis relies on the production of the antifungal lipopeptides. Mainly here we are talking about uterine surfactant in fungicides. So this type of substance will confer to the product the antifungal activity. For example, here just to give you some details about this type of substance, fungicides are known to exhibit strong antifungal activity against filamentous fungi, and they are known also to be very effective against different pathogens. Here we can, for example, talk about Rhizoctonia, Fusarium, Monilinia fruticola. So we are talking about a different type of fungi. With regards to uterine, the uterines has the capacity to inhibit the fungi and also the bacteria. So we have some action also against some kinds of bacteria. So in general, it will help to control the mold-related diseases, which is also a very big problem in case of trees, of frutal trees. And at the end, we are talking about surfactant, which are known for their biosurfactant activity. It will give you like the ability to get rid of the pathogen. Here, the photo that you are seeing there, we have been carrying out some lab essays. So at the Petri dishes, we compared the development of different fungi. Here we are, for example, Alternaria fusarium and Botrytis. So as you can compare the development of the fungi between the control and the plates where we introduced fungicide, and as you can see that the development has been stopped and have been inhibited to some levels because of the presence of this type of substance that will act on the development of the fungi and will try to limit the contamination of the pathogen. And also a very important mode of action is related to the induced systemic resistance. Here, several studies have been carried out with different strains of Bacillus subtilis, and they have indicated that the elicitation of the ICR, or the induced systemic resistance by Bacillus subtilis, is associated with the ultrastructural changes in the plant, where the Bacillus subtilis activates different pathways leading to the accumulation of the defense genes in the plant. So in a way, we are enhancing the defense system of the plant thanks to different pathways that will be activated once you introduce the Bacillus subtilis to the strain. And the presence of the Bacillus subtilis in the plant will give the plant the capacity to induce its own systemic resistance through a mechanism called, which is called a priming mechanism, which this mechanism will include different type of genes, will include the whole plant genome reprogramming, and in addition to that, the Bacillus subtilis will activate an RNA mechanism and will act on regulating the expression of several genes, and also by signaling different signaling pathways of the phytohormones, for example, as you can see here in the photo that we have joined. So here to sum up a bit, the product has been tested in different field trials, but also we have been carrying different lab assays, just like the photos that we have been seen before in petri dishes, or also in different tank mix to test the mixability of the product. And we have been able to receive a very good result with the product in different type of pathogens. And also during this field trials and also the lab trials that we did, we have been comparing the efficacy of the product with other biological products present in the market based on the same microorganism. But also we have been testing it in trying to compare the results to the results that we could obtain with a chemical strategy or chemical treatment. And we are going to see here, just to give you an idea about the efficacy of the product, we are going to see some trials, some result trials. So also very important aspect of the product is the broad spectrum of activity. So the product could give you a very good control to soil diseases. For example, Fusarium, Rhizoctonia, Verticillium, and also different type of foliar diseases, downy mildew, powdery mildew, botrytis, etc. And also, as we have been seeing before, thanks to the presence of the uterine of the lipopeptides, we are able to control some bacterial diseases, just like Pseudomonas or Xanthomonas, etc. So here we are showing some results from the trials that we have been carrying. Here we have some results with tomato, where we tested the product against botrytis. So we have three different dosage. We tested the product with the minimum dosage, which is 1 liter, then 2 liters and 3 liters. And then we have a comparison with an IPM strategy where we introduced the use of fungicide with the use of the higher dosage, which is 3 liters per hectare, and also a very conventional chemical strategy. And as you can see, even the use of the product, only the product, we have been able to show a very good control of the disease, and we have been able to reach even an efficacy that could goes to 60% and 70%. But also including the product into an IPM strategy will help a lot, first to reduce the use of chemicals, but also would help a lot to have a good control of the disease. Here we are visualizing some results that have been carried out in roses, also with the same pathogen, which is botrytis. And we have been testing also different type of dosages from 0.5, 1 liter, 1.5 liter. And also in this case, we have been comparing the results that we are obtaining with our product with another biological product based on a Bacillus subtilis existing in the market. And as you can see, we have been able, at least with the dosage, which the medium dosage of 1.5 liter, we have been able to reach a very good result, even similar to the result that you can obtain with the reference product. In this case, we are talking about an efficacy that could go to 90%. So that's we are offering a very control of the disease. And here, just to change a bit and to test the product and another pathogen, here we are talking about powdery mildew. And also same strategy. We were testing the product against a reference product existing in the market. And as you can see here, we have been achieving a very good result, even that could reach 80% of efficacy after 7 days of application, which is a very good control of the disease, of this type of diseases, after 1 week of application of the product. So here, just to give you an idea about the management of the product, and generally the dosage that we recommend are between 1 liter to 3 liters, and usually we recommend to repeat the applications at minimum dosage. We recommend it better than using the product only one time, because we are talking about a biological product that will need time to colonize the plant. So it will be better to repeat the application in order to enhance the presence of the microorganism in the plant, better than using the higher dosage and apply it one time. Generally, the number of application per season, it depends on the pressure of the disease, but generally we are talking about 3 to 5 application per season, and the days interval is between 7 and 10 days, as we have been seeing before in the trials. It's a product that could be perfectly integrated into an IPM strategy and will help a lot to reduce the use of chemicals and to give you a strategy which is an eco-friendly strategy. So just to sum up a bit about the advantages of the product. So we are talking about a product which gives you a broad spectrum of activity, will act on different pathogens and different diseases, from foliar diseases, soil diseases, bacteria, and so it offers you a broad spectrum of control, but also it offers you a good efficacy in comparison, as we have been seen before with other reference products in the market. It's a product which is a biological product, 100% natural, and also it's a product that could be applied and mixed with different type of fungicides in different type of plant protection product without any problem. So it's a product which is easy to use and easy to introduce into your strategies that you are using, or that you are using it at the moment.
Thank you so much, Mariam. Thank you so much for your explanation. I think now I can see a lot of people that are very interested by this new product that we're launching today. And for this launching, I'm very pleased to say that Elephant Vert East Africa are doing a special offer, mega sales, as I can say. So until the 20th of December, if you order 10 liters, you can have 2 liters free, and the price is 3,990 Kenyan shilling per liter. So you can, of course, like take orders from the nearest sales representative that you have, or I will also give you contact at the end that you can screen, and I will put it on the chat, so you can send us a mail or a WhatsApp, and we can answer directly for your orders. Thank you so much for everyone for this presentation. It was very, very nice. Thank you also for all of you to be here. And I can see now that we have some questions in the chat. So don't hesitate to ask all the questions in the chat. And the first question that I can ask is from EcoNature, from Francisco. And he asks, like, does fungicide has also microbial metabolism, organic matter, and fulvic acids?
Yes, I could give you an answer if you mind.
Thank you.
Okay. Other microbial metabolites, the bacteria creates its own metabolites. Once it's applied, when the product is in the bottle, it doesn't react. When you mix with water for the application, it starts to react. The bacteria, the spores start to activate. So then it starts as it common a life cycle, so it produced their own metabolites. Okay. Regarding other kinds of ads as organic matter or fulvic acids, no, the product hasn't any kind. The product is a fungicide, so it's just the formulation that is one of these its strong points of the product, and the Bacillus subtilis, that is the active ingredient.
Thank you, Enrique. And I have another question, so I think it will be also you will also have the answer. How is it possible that a microorganism survive in copper, and it should be impossible? Is there any other active ingredient with antifungal activities?
Okay, I'm not a microbiologist, so I cannot tell you. But we have a microbiologist in our facilities. She did the trials with our product. They test. Even we have external trials of a external lab that we did with the strain, and there is not a direct effect on the viability of the spores after the mixing of the product or the strain with copper. Okay. How it survive? I'm not microbiologist. I don't know how exactly to respond to give you an answer.
Okay, that's right. Thank you so much, Enrique, for your answers. I have another question. Is it the fungicide suitable in controlling anthracnose in avocados?
We have done some tests with against anthracnose. We haven't tested against avocado, but I think we could give you some tips for the managing of the disease. But maybe elephant bear, you can go through elephant bear, so we could move just not to give you here at the moment a recommendation, as not always is the same fields, ways of management in all the countries. So elephant bear has the experience, the wide experience in Kenya than we do. But yes, the product has activity and against anthracnose, but not tested against avocado.
Thanks so much, Enrique. I have another question that can salty or hard water affect the concentration during mixing?
Sorry, can you repeat, please?
Yeah, sure. Can the salty or the hard water can affect the concentration of the product during the mixing before spraying?
Regarding hard water, it isn't a problem. It is a problem. We have tested with different, there are 4 typical waters that you may test the product. We have done with any kind of problem, with any kind of hard water. With salty water, we have seen that the strain have resistance, but we should know the limit of the or the amount of salts that we have. In general way, with common salty water that we will apply to agricultural crops, it shouldn't be a problem to apply with salty waters.
Perfect. Thank you so much for all the questions. I see that we also have other questions that I'm seeing the time, and sadly we will have all to leave. But I can answer just about the product catalog and also the product availability. Please send us a text, WhatsApp text in December, or a mail, and we can answer. Of course, we can send also the product catalog. And for any registration outside Kenya, we under registration for other countries in East Africa. So it will be depending of the country. But I would like to say a big thank you to Miriam, to Abdelatif, to Enrique, to Paris, and to Luca, the speakers of today. Thank you very much for being here today. It was a pleasure to have you, and I would like to give a big thank you to all the persons that connected to this webinar. You will also be able to find this webinar online on our social media, so on LinkedIn, Elephant Vert East Africa, Facebook, Elephant Vert East Africa, and also on our WhatsApp channel. And if you have any questions, please don't hesitate to send a text or to send email. Thank you so much for everything, and I really wish you a very good day.